Ports are essential hubs of modern transportation and international trade. They are responsible for transferring as much as 90% of the world's goods, yet many still struggle to fully integrate automated systems into supply chain logistics where there is plenty of optimization that can still be done. Ports need an overhaul to reduce operational delays caused by vessel and truck congestion and overcome unexpected disruption. In this era, technological advancements have progressed drastically, and so the idea of smart ports instead was introduced. B5G, a beyond supporting new Internet of Everything services so as the path towards 6G, which can be known as beyond 5G. But what is 5G? 5G is the fifth generation technology standard for broadband cellular networks, which cellular phone companies began deploying worldwide in 2019, and it is the planned successor to the 4G networks which provide connectivity to most current networking devices. 5G networks will provide 15 times more speed, 10 times less latency, and 1,000 times more capacity than 4G LTE. This means 5G will be able to connect more devices and transmit more data than ever before, delivering fast connectivity and significantly enhanced user experience. 5G Internet utilizes millimeter wave for advanced transfer speed. To do that, more small cell towers are required for wider coverage for the millimeter waves. This technology can be known as massive MIMO. It increases the antennas, which will improve throughput and network efficiency. However, the increase in cell towers also increases the interference. Therefore, beamforming is applied and used to solve this issue. Beamforming triangulates signals in a way that packets moves and control to improve throughput and latency. Beamforming allows radio signal to be direct transmitted towards the receiver instead of transmitting in all directions. Now, we already know what is 5G and how 5G works. Traditional ports may adopt innovative technologies such as Internet of Things, big data, and cloud computing to become smart ports. This resolves challenges faced in previous generation of C ports. Smart ports are way more effective, efficient, and secure, resulting in an environmentally sustainable, economically efficient, and greater handling in high port traffic. For example, smart ports ensure data is transferred at fast rate to reduce task processing time. So, to implement a successful smart port, 5G technology is required to facilitate.
For challenges, traditional ports face challenges like lack of label, high cost, inefficient transportation load, safety, and security problems. Mechanical operators are the key to determine the efficiency of a traditional port. This is because a port requires many cranes to move cargoes to different areas, which require the mechanical operators to complete their tasks in a more efficient way. However, with the help of 5G technology smart ports, this can be addressed. For instance, mechanical operators can be replaced by 5G remote control systems to increase operational efficiency. Dangerous labor situations and security breaches can be prevented by installing CCTV systems enhanced with AI capabilities. This might be able to identify when safety requirements are not being met. It can be combined with AI to learn how to recognize patterns and objects in video feeds, automatically monitors birth, people, and traffic flow around the port area to make the site more efficient as well. Automation and analytics will allow for more efficient operations and reduce operational costs. 5G is expected to address such challenges thanks to its low latency, high bandwidth capacity, and the ability to support a massive number of devices, as well as its support for private network solutions and end-to-end applications. 5G will allow port operations to be smarter, more flexible, and secure to handle changes in technology, demography, and economy. There are a few examples on how 5G is used to enable smart ports. First, Unmanned ground vehicles (UGV) are used to increase efficiency. Unmanned ground vehicles require sensors to handle data and analyze process. Second, automation and remote control of cranes, drones, and robots. Third, CCTV system with AI capabilities. Fourth, remote control and monitoring of containers and vessels. Fifth, connected tugboats. Usually, when tugboats are moving a vessel around a port, they have little to no visibility of what each other is doing. The 5G network lets tugboats send data between themselves reliably in real time. It also powers pan-tilt-zoom (PTZ) cameras attached to tugboats that send images to the port control room. 6. AI solutions will be vital in enabling predictability in ports. If you can predict demand for berths and other areas of the port, you can streamline operations while giving port customers an enhanced experience. Linking up so many HD video feeds over a large area is typically very expensive.
TCP protocol is used in the transport layer to provide reliable end-to-end connection over unreliable links. 5G performance largely depends on reliable end-to-end communication. One of the mechanisms in TCP performance is congestion control. The conventional TCP congestion control algorithms are not able to differentiate between the potential causes of packet loss, which may result due to congestion or poor channel quality caused by the block edge or bin misalignment. The standard TCP congestion control mechanism is based on the additive increase multiplicative decrease algorithm, which incorporates four phases, which is slow start, congestion avoidance, fast transmit, and fast recovery. To achieve the requirement performance in 5G, the algorithm needs to adjust its congestion window size according to vehicle mobility and channel quality information. The size in long block edge situation should be reduced and maintained in short block edge situation. The success of congestion control in 5G enables low latency to be implemented. This is particularly essential for the use in smart ports. Autonomous drones are utilized in smart ports to allow inspection and maritime surveillance. Real-time video stream is one of its features, so the ports can be effectively monitored, and access can be easily tracked without the need to physically leave the room. The ability of 5G network architecture to overcome congestion allows no jitter when dealing with real-time application. Next, the network layer. Most of the seaports around the globe are equipped with a fixed machinery and connected to the network via cables. Mostly, trade around the world is carried out via seaports, and most of the operations are heavily dependent on humans. Recently, COVID-19 has dealt a major blow globally, resulting in shipping costs reaching an all-time high. A reliable network is required to trace and locate the containers, and to check their custom clearance reports and temperature. The existing 4G network cannot meet these requirements due to its limitation. We present the smart port use case, where network slicing that used in 5G or beyond can be deployed to ensure safe and efficient processes. Network layer can be known as the core network offers various services, such as providing the control and data plane functions and storage services. The client-server environment is provided at the application layer. After that, with the networking slicing of high bandwidth, reliability, and connection density promised by 5G, customers can install industrial cameras without laying cables, promptly update AI algorithms used on edge node cameras, improve the efficiency of flexible manufacturing, and automation. Moving on to physical layer, which is energy efficient mechanism. Wireless devices employ a sleep mode operation. The devices respond immediately upon obtaining a packet from a network to prevent delay. Similarly, the devices periodically monitor incoming packets on the network to avoid latency. In relation to the physical layer, this concept enables the establishment and termination of a connection to a communication medium, which improves the efficiency of smart ports. Integrated communication system of smart ports that incorporate 5G technology enable fast and high bandwidth communication. This supports a higher capacity of data and signal transmission in order to improve the energy efficiency in smart ports. The medium access control is a sublayer of the data link layer of the Open System Interconnection Reference model for data transmission. It is responsible for flow control and multiplexing for transmission medium. It controls the transmission of data packets via remotely shared channels. Medium access control layer perform collision resolution and initiating retransmission in case of collisions. It generates frame check sequence and contributes to protection against transmission errors. 5G is based on orthogonal frequency division multiplexing, a method of modulating a digital signal across several different channels to reduce interference. As a machine takes over human activities, the machine not only provides humans with more time and freedom, but also reduces human error and response time to rapid changes in today's dynamic business environment. In addition, the CPS fueled by IoT can enhance the machine-to-machine connectivity. In turn, it increases the opportunity for faster and more accurate communication. It allows multiple ports, carriers, and shippers to communicate and interact with each other easily and efficiently. The CPS can be a catalyst for establishing collaborative commerce that creates synergistic effects via electronically linked port activities and related business transactions.